All right, let's do some 3.5. One of these black pens is going to work amazingly well. That's okay. All right, so 3.5. Point, slope, form. So as we said earlier, repetitions, utterly logical. So point slope form, which is written y minus y1 equals m times x minus x1, where you have a point x1 comma y1, and you have a slope m equals, well, let's just say slope is m. Okay, and you plug those in here, here, and here. So those become numbers. And you are left with this y and this x, which are variables. So that will give you your equation. And again, remember an equation with two variables is really a relationship between a y and an x. So this y and this x stay as variables. The y1, m, and x1 all get plugged in as numbers, and that's how you make your equation. You would use this equation when you have a point and a slope. And what we plug in is a point and a slope, so we call it point-slope formula. Okay. I'll talk about a couple things here. One being, this is really just a shortcut. Okay. The questions on the homework will say start with this and then rearrange them to be in y equals mx plus b format. And we could just go directly to y equals mx plus b format without ever knowing this formula. So I want to get that across. I know I've said it multiple times already. So let's do an example from 3.5. Let's start with number 2, the same number we start with in every section, right? A short, direct, immediate attempt. So it says write the equation of a line, and it gives us a point that the line passes through, just any old point, not the y-intercept, and then it gives us a slope. So number 2, it says the slope is 6, and it says the line passes through 3, 1. Okay? So we're going to start with our y minus y1 equals n x minus x1. What we're going to do is we're going to say, okay, here's our m and our x1, y1. And remember those subscripts, the little 1 below, are just a name. It's saying I have a point. Let's call this point our first point. If we have more than one, we'll call the next one x2, y2, the next one x3, y3, etc. Okay, so plugging these in, we get y minus 1 equals 6. That was a terrible 6. 6. And then x minus 3. Again, this y and this x stay there as the variables that make the equation. Okay, so there, we have the equation of a line. And in a lot of advanced math classes, you could just stop there. Okay, as we're really practicing y equals mx plus b, we're really practicing graphing. The second part of this question says, then use the point-slope formula of the equation to write the slope-intercept form. In other words, rearrange it to be y equals mx plus b. So here's our first part of the answer. Second part of the answer, let's distribute. This is the same thing as this. Then let's get y equals, and to get y equals, all we got to do is get rid of this plus 1 and we're done. So plus 1, plus 1. So now we have y equals 6x minus 17. There we go. Okay, so direct application, you plug in the point you have, you plug in the slope you have. Okay, so just to write two things explicitly. So I'm going to show you now the alternate method to find the equation. One, direct application. If you have a point and a slope, plug it in, done. Okay? However, memorization for me has always been a struggle. So as a student, I never memorized this formula. Instead, I got really good at y equals mx plus b, and I used that in every application. Just like true story, I skipped 6th grade math and never learned decimals. I think I told you guys this. And so I used fractions for everything. When a problem was in decimals and I needed to answer in decimals, I turned it into fractions, solved the problem in fractions, turned it back into decimals, because I had no idea how to multiply decimals until I was like a junior in high school. And I was in like calculus, or I was doing math contests with my friends, and one day I asked my buddy, I was like, so how do you multiply fractions? And he laughed at me, and I was like, no, I'm serious. He was like, what? Or I mean decimals. He's like, are you serious? I was like, yeah, I don't know how. So I got really good at y equals mx plus b, and I completely avoided this, and you don't need it. So I would suggest that. However, if memorization is your thing, just memorize that, and you can use it.
So how would you solve that just using y equals mx plus b?
Yeah, so that's what we're going to do right now. So the alternate method, whoa, okay.
And this is if you have a slope and a point?
Yep, same thing. So here's alternate method. Okay, so same example. Okay, so I'll tell you the step here, and then I'll do it over here. Okay, so step one is plug in the slope to y equals mx plus b. And leave the b. Okay? So we know it's y equals 6x plus b. Okay? And number two is, what else do we know? We know that this point is on the line. And now us all being super comfortable with section 3.1, what does it mean that our line passes through 3.1? Yeah, but I mean, what does it mean for a point to be on the line? Remember, what does it mean for the point 3, 1 to be on the line?
It's a solution to the equation.
It's a solution to the equation. So if we plug it in,
It's correct answer.
Yeah, it's the correct answer. So, since we know a point on the line, plug in that point. And it will work. Okay, so we plug in that point. So 2 is, for y, we plug in 1, equals 6 times, for x we plug in 3, plus b. And look, we know when we plug that point in, it should always work. So we know we can find b, right? We just have numbers in b. So 3, solve for b, and 4, write the equation. Okay, so just literally to y equals mx plus b, plug in the slope and the point. And you have y equals mx plus b, here's m, here's y, here's x, you have everything except for a b. And you know it's a solution, so you know when you plug it in it'll work, so you literally just fill in the y, the m, and the b, or x, and you're left with just the b. That's it. So you just get super comfortable with y equals mx plus b, plug in mxy, and you're left with, so you get 1 equals, this is step 3, 1 equals 18 plus b, minus 18, minus 18, b equals negative 17. And then so step 4 is write your answer. Too many people stop there and say b is negative 17, that's not the answer. It asked for the equation in y equals mx plus b form. So y equals 6x minus 17. Okay? So I would always do it that way. I would write it with my slope in it, and I'm not kidding you. If I ask this question, it could be a paragraph question of, you know, the slope is this, it passes through this, find the equation of the line. If you just write y equals 6x plus b, I'll give you half credit. Because again, when I grade you for the equation, half the credit is the slope, half the credit is the y-intercept. So if you write y equals 6x plus anything, I'll say, yeah, you got the slope right, half credit. Okay, I tell you the slope. If you just write y equals 6x plus b and have no idea what to do next, that's half credit. So start with that. And then you know you have a point on the line, so plug it in. Again, get really comfortable with 3.1. If it's a solution, if it's on the line, just plug it in and it should work. And that means b is negative 17. So y equals 6x minus 17, or plus negative 17, however you want to do it. So I would always use this method. If you want to learn the new formula, absolutely do it. Okay? So let's do another example. Okay? Because then it gets a little harder. I forgot to do one type of problem for one section. Dang. Hold on. We were running short on time. That happens sometimes. Alright, so just one more to practice. Okay, here is number 6. Okay, it gives us a slope of -4. It gives us the path passes through the point -5, -2. So let's do it both ways. So first, let's do it with the equation. So this new fancy equation is y minus y1 equals m times x minus x1. So let's plug it in. What do we got?
We've got a -5.
Yeah, so y minus, but first we're doing y minus y1. So this is x1 and this is y1. So first we got y minus -2 first equals -4 yeah, minus 5. There we go. So we could do it that way and then just simplify. So minus the -2, that's y plus 2 equals -4, this is x plus 5. And we distribute including the negative. So y equals, y plus 2 equals -4x minus 20. Just moving, oh, I'm writing so many negatives wrong here. Minus 2, minus 2. So we got y equals -4x minus 20. Okay? Straightforward. Plug it into the equation and just kind of simplify it a little bit. That works. However, on the test, you'd have to memorize that. Right. Or alternatively, we go, all right, well we know already, half credit, the equation of this line is y equals -4x plus something. Okay, half credit, done, great. Okay, then what do we know? We can, we can plug in the points and it should work so we can find b. So plugging in, we get -2 for y equals -4 times -5 plus b. And then we just solve. Okay, so -2 equals 20 plus b, subtract the 20, subtract the 20, and we get b equals -22. Now, too often people stop there. Just like on a word problem, they solve for x and go x equals 2. And I'm like, but the word problem's asking for the dimensions of the rectangle. So that would be 2 answers. Right, same thing here. Don't stop there. Finish the problem by saying it's y equals -4x plus -22 or minus 22. You get the same answer either way. Neither one is essentially easier than the other. One requires a deeper understanding of y equals mx plus b, and one requires memorization. I always prefer the deeper understanding. Just as a side note, which I find interesting, this isn't even a new formula to memorize. It's actually a formula you already know. This is just m equals y2 minus y1 over x2 minus x1, which is not even an equation. It's just literally the rise is I went from here to here, so what's the difference? I went from here to here, so what's the difference? So very logical, rise over run is basically it. And here, usually we know this point, and we know this point, and we want the slope. But let's say here, what if we knew the slope and knew this point, but we didn't know these? So instead of calling it y2 and x2, let's just call it a general y and x. And then let's say, hey, you know what? I want to get rid of this fraction, so let's multiply both sides by x minus x1. And so this cancels, and we get, sure enough, y minus y1 equals m times x minus x1, which is the point slope formula. So all it is the slope formula, except instead of plugging in 2 points and getting a slope, you plug in a point and a slope, and then you just leave these as variables and say, well, what's the relationship have to be between this point and this point to get that slope? And that is the equation. Okay, so it's not even a new equation. So much of math is so interconnected that, you know, if you just go through it being like, oh my God, one new thing that somebody just invented, but actually it all simplifies down. And so, you know, it was kind of like the moment I was, I think, teaching at the time when I realized that all those, you know, whatever you guys have done in the past with trig, but all those trig identities like this and tangent squared plus 1 equals secant squared, when I realized all of these things were really just the Pythagorean theorem, I was like, what? It's all just Pythagorean theorem, there's nothing new to memorize? It just blew my mind. So, it's the same idea, right? This isn't a new formula, it's just the same, how do you find a slope, which is rise, run, so you subtract, Okay. So, I'm going to give you one last thing to think about, and then after that, I'm going to do one last example with you. Okay. All right. So the one last thing I'm going to give you, which is always on the the web, is I like flowcharts. It's like a logical process. So how to find the equation of the line. Okay? You basically get, what information do you have at the beginning?
Slope and line.
So that's right now. Yeah, so basically you got three cases. Either, number one, you have the slope, and you have the y-intercept. That's easy, right? If you have the slope and the y-intercept, you just plug it into y equals mx plus b, right? You're done. Okay, easy. Number two is,
Slope of point.
yeah, what if we have a slope and a point? Okay, and that's what we did today. You got two choices here. You can either, for option 2, use y minus y1 equals m x minus x1, or you can use y equals mx plus b. That's what we did today. The only other possibility, the only other problem they could say find the equation of, other than maybe a horizontal or vertical line, is what if they gave you 2 points. Okay, wow, way harder. What do you do first?
Yeah. Plug in the values of 2 points in the first thing.
Yeah, maybe.
Because you gotta find the slope on that
Find
side.
the slope, right? So we find the slope. And then, you're right there, right? So really, you've only got two situations. Either they give you the slope and the y-intercept, so you just write the equation. Or, you have a slope and a point, which is super common, right? You're gonna see probably at least 3 of these on the test. The test is about a week from today. I have people say, what, after 4th of July weekend on a Monday? And I was like, oh, I forgot there's a holiday. So maybe it'll be Tuesday. But the problem is, then that means Monday we're going to start chapter 5. We're going to start polynomials. And I'll be like, get all this in your head today. And study for the test. Whereas if it was Monday, then it would be just work on chapter 3 and 4 and have 3 beautiful studious days to relax and focus. But that won't be holiday weekend. So anyway, it'll probably be Tuesday now that I realize that. But we'll figure it out. And the only other exception is either you're given 2 points, so the very first step is find the slope, and then boom, you're in this condition. Or the one other possibility is they give you some sort of word problem where it's in code, where they say, okay, you have this point that the line passes through, and it's parallel to, perpendicular to, which is just code for find the slope, right? If it's parallel to, it has the same slope as. If it's perpendicular to, it has the opposite reciprocal as. But either way, they're basically saying, I'm giving you a hidden slope that you can find with 1 step or so, and then a point. Okay, but this is really the bread and butter problem, where you have a point and a slope, and then you need to get really used to either your method of using the point-slope formula that we just learned today, and that's a formula you want to memorize, or getting really comfortable with y equals mx plus b, and just plugging in the slope, plugging in the points to find b. Yeah.
Okay, scenario, if one of your points, let's say you're given 2 points, and one of your points is 0 minus 3, you already have a y-intercept.
If you realize that, if not, you do it this way, you get there anyways.
Okay.
Yeah.
But you can, if one of your points is
the y-intercept,
and there's the y-intercept, then you can.
But the nice thing is let's say you have y equals 5x plus b, and you're like, and I'm just going to plug in my point that's 0, negative 3. Well, look what happens. You get negative 3 equals 5 times 0 plus b. b plus 0 equals negative 3. So b equals negative 3. So it takes half a second extra if you don't see it conceptually. But obviously, if you see it conceptually right away, and you go, I've got my y in, then you can just erase this negative 3, I'm done. Whereas if you plug it in, it takes you an extra few seconds, then you get the same answer, yeah. All right, it's a bread and butter problem. So let's do one problem like that that's just, here's 2 points, find the equation of the line, and that's where we'll leave off. Okay, all right, so problem like, let's even do one that's like in code, okay? Here's 26. I love the hidden messages. Okay, so it's passing through one comma negative 3 with an x-intercept of negative 1. Okay, so what situation is it really? Right, there's only 3 possibilities. Which situation is it?
Point slope?
Not a slope. Not a slope.
No, you need to have.
To go number 3.
Yeah, why number 3?
Because you got to find the slope.
Yeah, but why is it number 3?
Because you have 2 points.
What's the second point?
The intercept.
Yeah, the x-intercept is just a point. What's this point?
Negative 1.
Minus 1, 0.
Yeah, minus 1, 0. So that was it. That was the code, right? As soon as you see that, it's only ever one of these 3 situations. Really, I mean, number 1 doesn't even exist, because still, slope and the point, the y-intercept's just a point. You could still use this. It's just a really easy one that if you see you specifically have the y-intercept, you just write the equation. But that's it. As soon as you get there, personally, I would use a piece of graph paper to count. I would say, okay, I'm at negative 1, 0, and I'm at 1, negative 3. So what's my slope? I would specifically say I went down negative 3 and right positive 2. So my slope is negative 3 over positive 2, or negative 3 halves.
Positive 2. Yeah, that's probably right.
Right 2, yeah. But you could absolutely use the formula. You say, hey, my formula is y2 minus y1 over x2 minus x1. Okay? So let's call either point 1 and 2. Doesn't matter. Let's just do this one as the first point, because it's the first one I came to. And here's the second point, because it's the second one I came to. You get the same slope either way. The key being 1 and 1 go together, 2 and 2 go together, and you put them in the right spots. But here we go. So we got equals y2, 0, minus y1 is negative 3, so minus a negative, over x2, negative 1, minus x1, 1. And then being just super careful with negative, you can see why there's so much room for mistakes. You can flip one, put one on the top and the bottom, left, right. So much room for error. So this is 0 plus 3. This is -1 plus -1. So it's 3 over -2, or -3/2. Okay, so first thing we did when we had 2 points was find the slope. And now it's like every other problem at the beginning of this section. Now we have n equals -3/2. And we have not just one point, we have either point. So people might ask me, which point do we plug in, right? And I'd say, who cares? Qualquier. And whatever you want. Okay, so what are we going to plug in? Yeah, let's plug in -1, 0. It looks easier. So I'm going to use y equals mx plus b, and I'm going to say this is y equals -3/2 x plus b. If you want to use the other formula, totally okay. In general, in this class, whenever it comes to a problem, I'll just use y equals mx plus b. The other formula, specifically, just plug it in, rearrange. Okay, so now let's plug in our point. So now plugging in our point, we know y is 0 equals -3/2 times x is -1 plus b. So we have 0 equals +3/2 plus b. So not scared of fraction. If I have b plus a number, I want to get rid of it, so I just subtract the number. Right? And so now I have b by itself is equal to -3/2. Whoa, the slope and the y-intercept are the same. That doesn't happen that often. It's kind of like winning the math lottery. So -3/2 x minus 3/2. There we go. That's it. Okay, so every situation is one of these three, and really, number one is just silly. It's just, oh, the point you have is the y-intercept, so it's special. And if you have 3, you find the slope, and boom, you're in 2. So really, it all comes down to getting super comfortable with finding the slope, or finding the equation if you have the slope and the point, regardless of which method is easier for you. But get really used to solving this, because I'm telling you, you'll do it a lot for homework, and then it will be at least 3 problems. So we're talking at least 15 points, maybe 20 or more points at this coming test. Let's say 15 or 20 points. It's like a quarter, a fifth of your test. I mean, a fifth or a sixth of your test, not a quarter. All right. That's a good spot to be. So you guys got 20 minutes to work on this, direct, immediate application of it, and then, yeah, tomorrow we'll start chapter 4, and all chapter 4 is what if we have 2 equations? Okay, we'll do it on a graph, and we'll do it without a graph, but it's the same idea. You got equations of the y and x's. Now you just have 2 instead of 1.